In the vast, uncharted expanse of the cosmos, a diminutive, human-crafted artifact continues its solitary journey, a testament to our species' indomitable spirit. Launched in 1977, the Voyager 1 spacecraft, a relic of a time when home computers were but a dream, has defied all expectations, surviving half a century in the inhospitable environment of deep space. Its twin, Voyager 2, accompanied it on this journey, and together they provided humanity with our first glimpses of Jupiter's tempestuous storms, Saturn's mesmerizing rings, and the icy secrets of worlds once thought to be lifeless. As their cameras shut down and their batteries aged, they continued their voyage, venturing beyond Pluto, beyond the Kuiper Belt, and beyond every boundary we had ever drawn around our solar system. Voyager 1 became the first human-made object to cross the heliopause, the invisible frontier where the solar wind gives way to interstellar space. Yet, as it crossed this line, something unusual occurred. The magnetic fields didn't shift as they should have. The plasma density spiked, yet the field direction remained constant, as if the probe hadn't left our solar system at all, but had entered a mirror image of it. For years, scientists believed that Voyager 1 had truly escaped into interstellar space, but new data began to tell a different story. The probe's instruments, 4 of them still functioning, recorded subtle fluctuations in plasma waves, like echoes bouncing between unseen walls. The heliopause, the supposed edge of the solar system, wasn't smooth. It was rippling, and the ripples were growing stronger. Then, in 2018, Voyager 2 crossed the same boundary and detected the exact same magnetic alignment, the same density spikes, the same eerie lack of transition. 2 spacecraft, 6 years apart, entering supposedly open space, both finding themselves trapped in identical magnetic conditions. NASA's models couldn't explain it. The simplest conclusion, that the probes hadn't actually left the sun's influence, raised an even bigger question. What then is really out there? Was the heliosphere not a bubble, but a barrier? And if so, what was on the other side pressing back? In late 2024, Voyager 1's data stream changed. Its cosmic ray detector, operating decades past its expected lifespan, began registering short, rhythmic spikes, each precisely 11 minutes apart. At first, NASA's Deep Space Network dismissed it as system noise caused by radiation interference. But the spikes were perfectly timed, and their amplitude rose in exact correlation with the background plasma waves. Then came the transmission glitch. Voyager 1's antenna, which hadn't moved in over a decade, suddenly reoriented itself by half a degree. The maneuver was tiny, almost imperceptible, yet it required a deliberate command from its attitude thrusters, commands that had not been sent. The spacecraft had turned back, not toward the sun, but toward the direction of the magnetic flux it had been detecting for months. And when it did, the data changed. The rhythmic spikes merged into a continuous tone, a steady signal oscillating just below the threshold of human hearing. When the waveform was decoded, it formed something that no one at NASA wanted to believe. A repeating harmonic ratio matching the fundamental frequencies of the hydrogen atom, the same constant used to encode the golden record, Voyager's message to the stars. This discovery split the scientific community in two. Some argued it was a coincidence, a trick of plasma resonance. Others thought something far more profound had occurred. Voyager 1 wasn't detecting a natural field, it was hearing its own transmission reflected back. The data patterns were identical to the probe's own signal profiles from decades earlier, but inverted, as if bouncing off an unseen boundary. A reflective membrane surrounding the heliosphere, absorbing and returning signals like an echo chamber at the edge of creation. If true, it meant that the boundary between the solar wind and interstellar space wasn't an exit, but a mirror. The signal grew stronger for 3 weeks, then suddenly vanished. When engineers at JPL analyzed the final frames, they noticed one last faint voltage fluctuation across the magnetometer. It wasn't random. It spelled out a binary sequence that matched the time code of the Golden Record's very first track, the sound of greetings from Earth. Voyager 1 hadn't just looked back. Something had looked back at it. The engineers at the Jet Propulsion Laboratory worked around the clock. What they had in front of them was a faint and fragmented data stream, almost erased by cosmic noise, but within it hit a pattern that refused to die. When they filtered the raw binary through noise reduction and compared it with Voyager 1's historic transmissions, the resemblance was undeniable. The frequency envelope matched one of the probe's original calibration tones, but reversed and phase shifted as though bounced off something vast and structured. Using machine learning reconstruction models, NASA's deep space team converted the waveform into a 3-dimensional spectrogram. What emerged on the screen froze the room. The signal wasn't chaotic, it had symmetry. 6 repeating spikes formed a perfect lattice, a hexagonal resonance similar to the crystalline arrangement seen in magnetized plasma chambers. The implication was staggering. Whatever Voyager 1 had encountered was not a diffuse gas cloud or random field. It was an organized boundary, behaving like a membrane capable of reflecting and shaping electromagnetic energy. Some called it the interstellar wall. Others simply referred to it as the mirror. The discovery couldn't stay contained for long. Within days, observatories across the globe began tuning their antennas to the same frequency range. The European Space Agency's Rosetta Relay, the Indian Deep Space Network, and even private arrays like Square Kilometre Array South reported identical phenomena. Tiny mirrored pings arriving exactly 19 hours after every Voyager 1 transmission. At first, the time delay seemed meaningless, until one mathematician at MIT noticed that 19 hours corresponded precisely to the travel time of radio waves, bouncing between Voyager 1 and an object located 22 billion kilometers from Earth, the other side of the heliopause. That meant the signal wasn't isolated. It was part of a 2-way feedback loop, as if an external structure was not only reflecting, but amplifying the probe's transmissions. The more data Voyager sent, the stronger the return became. Then came the truly impossible moment. The same mirrored frequency appeared on Voyager 2, billions of kilometers away on a completely different trajectory. 2 spacecraft, separated by the size of the solar system, were now receiving the same rhythmic reflection synchronized to the second. Once both Voyagers began receiving the identical signature, NASA tried to decode it as a message. But instead of language, what emerged looked like geometry. By plotting each frequency spike over time, scientists noticed that the peaks formed a pattern, an expanding spiral intersected by radial lines, like a map viewed from above. When the coordinates were cross-referenced with star catalogues, the intersections aligned with local interstellar clouds, forming a corridor stretching outward toward the direction of Ophiuchus. The pattern repeated every 72 hours, each cycle adding new details as though layers of information were being drawn across the void. The data was subtle but deliberate. The map wasn't pointing outward, it was folding inward, converging back on the sun's position. It was as if the signal were charting us. When engineers converted the numerical ratios into audio, a haunting low-frequency hum emerged, oscillating precisely at the same pitch encoded on Voyager's golden record. 115 hertz, the tone representing the hydrogen atom's fundamental frequency. Somehow, something beyond the heliopause was speaking in the same mathematical language we had once sent into the cosmos as a greeting. Then came the moment no one expected. On February 4th, 2025, at 243 UTC, Voyager 1's orientation sensors triggered an automatic correction maneuver, one that had not been commanded by mission control. The probe rotated 7 degrees, aligning its high-gain antenna not toward Earth, but towards the exact coordinates indicated by the geometric pattern. The maneuver consumed precious hydrazine fuel, yet the thrusters fired flawlessly. For 11 minutes, Voyager transmitted a high-power burst straight into the darkness, as if answering a call. Every dish in NASA's deep space network registered a dramatic power drop during the transmission, followed by a brief silence. And then a return signal far stronger than anything the spacecraft should have been capable of detecting. The echo wasn't in radio. It arrived as a low-frequency gravitational fluctuation, a ripple measured simultaneously by the LIGO detectors on Earth. For the first time in history, a human-made machine had sent a signal into the interstellar abyss, and space-time itself had responded. When the gravitational echo arrived, every model in physics broke. It wasn't just a ripple in space-time. It was a patterned wave encoded with intervals and harmonics that matched Voyager's transmission precisely. In the LIGO data, the wave didn't behave like a random gravitational fluctuation. It carried a rhythm, a symmetry, an unmistakable structure. When scientists reconstructed the waveform using three-dimensional Fourier mapping, what appeared wasn't noise. It was a shape, a toroidal lattice pulsing and breathing like a ring of energy folding inward upon itself. The coordinates embedded within its phase shifts matched the exact position of Voyager 1, and for a single moment its frequency converged perfectly with the golden record's bass tone. It was as if the universe itself had played back our message. The first interpretation was chaos. Some called it interference. Others whispered something else, that Voyager had touched the event horizon of an artificial construct, a gravitational shell surrounding the solar system like an invisible boundary, a system not built to trap us, but to contain something else. NASA went dark. Within hours, all live telemetry from Voyager 1 was redirected through encrypted relays. Officially, the spacecraft was experiencing data corruption. Unefficiently, what they had seen terrified them. The final packets received from the probe contained a compressed burst of raw measurements, far denser than anything Voyager systems should have been able to produce. When the binary data was expanded, it revealed something staggering, a repeating code embedded in the plasma readings. The pattern translated into a sequence of 6 recurring numbers: 1, 0, 1, 1, 0, 1. A pulse repeating every 11 minutes, identical to the signal Voyager had first detected weeks earlier. But this time the source wasn't beyond the heliopause. It was behind the probe inside the heliosphere following it. That was when the Deep Space Network captured something no one could explain. A second signal, not from Voyager 1, not from Earth, but from somewhere between them. The transmission matched the probe's original frequency, but was stronger, far too powerful to be reflected light or radio bounce. For 19 minutes, it mirrored every Voyager transmission in real time, duplicating its telemetry down to the last bit. It was as though there were 2 Voyagers communicating, one human, one reflected, separated by billions of kilometers, each echoing the other in perfect synchrony. And then, just as suddenly as it began, it stopped. The data froze, the instruments fell silent, and the only thing left on the carrier wave was a faint oscillation, not in radio but in the frequency of hydrogen itself, the same frequency used on the golden record to represent the language of intelligent life. In that moment, NASA's physicists realized the unthinkable. The boundary Voyager had reached wasn't the end of the solar system. It was a mirror field, a curvature in space-time where electromagnetic radiation folds back upon itself. Voyager hadn't found the edge of the sun's influence. It had found the point where space looks back. The gravitational echo wasn't an answer from the stars. It was the sound of our own message being caught and returned by a structure too vast and too deliberate to be natural. And inside that reflection, hidden in the smallest harmonics of the wave, was a timestamp, a countdown measured in seconds. When decoded, the timestamp aligned with the year 2031. No one at NASA could explain it, but off the record, one scientist described it as a synchronization marker, as though whatever lay beyond the heliopause had just begun calibrating itself to our system. "It's not coming toward us," she said. "It's aligning with us. For the first time in human history, we had reached out far enough into the darkness for the universe to notice, and it had reached back." Voyager 1 remains silent now. Its signal, once steady, has degraded into static that fluctuates every 11 minutes, the same rhythm it detected before turning back. To the public, it's dismissed as a malfunction, but to those who still monitor the deep space frequencies, the pattern hasn't stopped. Every 11 minutes, a faint pulse echoes through the dark, not from the probe itself, but from the space around it, as though something out there is still repeating our message, waiting for us to send another. So if this story made you wonder whether Voyager really discovered something at the edge of the known universe, if you've ever felt that maybe our first message into the void was never lost, but heard, don't look away. Subscribe to this channel because the day Voyager's silence breaks again, we may finally learn whether we were the first to reach out or the last to realize we were never alone.